Hello my dear student, secondary 1. Now we study unit 1, physical quantities and measuring unit. It is including two chapters, physical measurements and scalar and vector quantities. Physical measurements. By the end of this lesson, you will be able to identify the fundamental and derived physical quantities and derive the dimensional formula of physical quantities and state the fundamental physical quantities in the international system and their unit. Finally, you can name the tools used to measure length, mass, and time. Physical measurements. The measurements translate our daily observations into quantitative amount that can be expressed in terms of numerals. For example, in the PM balance, the measurement of an unknown mass in one pan, which is balanced against the known masses in the other pan, is actually just a process of comparing the unknown mass with the known masses. Thus, the measurement process is the process of comparing an unknown quantity with another quantity of its kind to find out how many times the first includes the second. Key elements of measurement process: physical quantities, measuring tools, measuring unit. First, physical quantities. The quantity which we are dealing with in our daily life, such as mass, length, time, are called physical quantities and can be classified into fundamental physical quantities and derived physical quantities. The fundamental physical quantities, they are physical quantities that cannot be defined in terms of other physical quantities like length, time, and mass. The length of the body equal L. For example, the length of body is considered a fundamental quantity. Why? Because no other physical quantity is needed to define length. This means length is defined by itself. Okay? Derived physical quantities. They are physical quantities that can be defined in terms of the fundamental physical quantities. For example, volume, speed, and acceleration. The volume of, for example, the volume of occupied equal length time width time height. Length considered L, while width considers as a length, L height length. So the volume of occupied is considered a derived quantities because the volume is defined in terms of lengths of occupied dimensions. This means volume is derived from length. In ancient time, man was using parts of his body as tools of measurement, such as the arm and the hand span and the foot, as a tools to measure length. Natural phenomena as tools of measurement, such as the time, as the sunrise, sunset, and the moon phases to measure time. Recently, the measuring tools have been developed in the context of the great industrial evolution next to the Second World War. So these tools were very helpful to man in describing phenomena accurately and exploring facts. The used measuring tools depends on the physical quantity to be measured. So the first step to measure any physical quantity is to choose the suitable measuring tools. In this section, we will show some ancient and modern tools used for measuring length, mass, and time. As we see, the measuring tools for lenses, ruler, meter tab, and micrometer, Werner Kleber. Number 2, mass, Roman scale, beam balance, analog scale, digital scale. Time, hourglass, clock, stopwatch, digital watch. Third, measuring unit. Measuring unit, each physical quantity, either fundamental or derived, has a measuring unit because quantity without its unit is meaningless. For example, the mass of a body equal 5. What is the meaning of the mass of a body equal 5? The absence of measuring unit makes us puzzled because we cannot estimate the mass. 5 what? 5 kilos, 5 gram, 5 tons, 5 6. This meaningless. But if we write the mass of a body, equal 5 kilogram, that means the quantity is fully clarified when there is a unit of measurement. Okay? There is a number of systems to specify the measuring unit of the fundamental physical quantities, such as French system, British system, metric system. In French system, the French system called Gaussian system, the length measured by centimeter, the mass measured by gram, time measured by second. In British system, the length measured by foot, mass measured by pound, time measured by second. In metric system, the meter measuring unit of length, the kilogram is the measuring unit of masses, second measuring unit for time. In the General Conference of Weights and Measures in 1960, scientists agreed to add other 4 fundamental physical quantities to the metric system to have an international system of units, which is used in all scientific fields all over the world. The following table gives the measuring units in the international system. The length measured measured by meter, mass measured by kilogram, times measured by second, electric current intensity measured by ampere, the absolute temperature measured by Kelvin, amount of material, mole, luminous intensity, candela, angle measure, radian, solid angle measure, all other international system units can be derived from these fundamental base units. For example, the measuring unit of volume is meter cubic, which is a derived unit from the measuring unit of length, meter. Okay? All units of other system can be converted into international system. A physical quantity is usually described by a numeral and a unit of measurement, but in some cases these values are very huge or very small. It is very difficult to read such values. We prefer to express these values in the form of power of 10. As we see, we can write this number by 10 power 4 and this number 10 power negative 4. This way of expressing the magnitude of physical quantity is known as standard formula. The factors 10 power positive or negative x are given specific prefixes. This is shown in this table. Nano, the factor 10 power negative 9, its prefix nano, its symbol n. 10 power negative 6, micro, symbol, this symbol mu. The factor 10 power negative 3, milli, so its symbol m. 10 power negative 2, centi, c. 10 power 2, hecto, h. 10 power 3, kilo, k. 10 power 6, mega, and 10 power 9, giga. For example, a car moves a distance of 5 kilometers. Express the distance moved by the car in millimeter. 2. We change the measuring unit from kilometer to millimeter. Kilometer equal 10 power 3, millimeter equal 10 power negative 3. So step number 1, remove kilometer, remove prefix kilo, k, put its value, so that the value equal 5 times 10 power 3. We remove the prefix and put its value. Now I changed the measuring unit from kilometer to meter. Step number 2, it changed the meter to millimeter. We write millimeter. So we divide the number by the value of millimeter, 10 power negative 3. Divide 5 times 10 power 3 divided by 10 power negative 3. The value become 5 times 10 power 3 times 10 power 3 equal 5 times 10 power 6 millimeter. It's clear? We must remember that when we times two number the same base, we write the base and add the powers. When divide the same number, the same base, we write the base and minus their powers. Yourself, the radius of a thin wire was measured by micrometer. It was found to be 3 micrometer. Express the radius of the wire in kilometer. 3 micrometer equals 3. We remove micro and write its value to change to meter, and times the value of divided by the value of kilometer. So the value becomes 3 times 10 power negative 9 kilometer. Thanks for listening. I wait you in the next lesson, inshallah, part 2 in the first lesson. Goodbye.